Hey everyone, so today I'm going to solve this circuit using nodal analysis. In this circuit, we have to find V0, which is voltage across this point and this point, which we supposedly say node. So, first step is to consider this one as a ground node. And let's consider these three nodes, V1, V2 and V3. So, let's consider node V1 first. At node V1, basically we use KCL. That is, if we consider I1 current flowing to that direction, I2 flowing through that direction, and I3 flowing through this direction, then I1 plus I2 plus I3 equals 0. So, what's I1? I1 is V1 minus 12 over 4K. V1 minus 12 over 4. Plus I2 is V1 minus V3 over 6 plus 2 because they are in series. That is 8K. Plus I3 is V1 minus V2 over 6K. That is equal 0. So one of the better way to solve this kinds of problem is separate the base. 12 over 4 is 3 plus, that is going to be 3, and plus V1 over 8 minus V3 over 8 plus V1 over 6 minus V2 over 6 equals 0. So we get, let's take V1 at one side. 1 over 4 plus 1 over 8 plus 1 over 6 gives us 13 V1 over 24, and V2 is V2 over 6 and minus V3 over 8 equals 3. So let's take 24 is common, and 13 V1 minus V2 times 6 times 4 is 24, so 4V2 minus 8 times 2 is 24, so 3V3 equals 3. So we get one equation, 13V1 minus 4V2 minus 3V3 equal 3 times 24 is 72. You can skip the calculation part if you want to know the nodal analysis only, but this is one of the way I used to solve these kinds of equations. So let me remove this so that I can see my circuit while solving the other nodes, and let me keep this over here. So this is our first equation, and now let's take another node, that is at node V2. Again, let's consider this node. So again use KCL. That gives us current flowing to this direction, this and this. So I1, let's suppose this is I1, I2, I3. So I1 plus I2 plus I3 equals 0. So now, what's I1? I1 is current flowing through these nodes, and V2 minus V3 over 4 can give us I1, plus I2 is V2 minus this ground node over 8. Always know that ground node means V0 equals 0. Don't confuse yourself with this V0 and this V0. Let's take this as, okay, let me take as Vn. V1 is 0 because it's ground node and there is no voltage flowing down that one. So V2 minus 0 over 8K plus V2, I3 is V2 minus V1 over 6K equals 0. Now let's solve this as usual. v2 over 4 plus v2 over 8 plus v2 over 6 minus v3 over 4 minus v1 over 6 equals 0. So adding up all the v2, 1 over 4 plus 1 over 8 plus 1 over 6 gives us 13 v2 over 24 minus v3 over 4 minus v1 over 6 equals 0. So 13 v2 minus 4 times 8 is 4 times 6 is v3, 24. So 6 v3 minus 6 times 4 is 24. So 4 v1 equals 0. That gives us our equation 2. And now let's arrange this in v1, v2 and v3 format. 13 v2 minus 6 v3 equals 0. That gives us our equation 2. So again, let me remove all these things and put this at the top. So this is our second equation. And now finally let's take our third node. That is, I'm going to write it here, at node v3. Again we use KCL. That is, current flowing through this direction, this and this, I1, I2 and I3. So I1 plus I2 plus I3 equals 0. And now what is I1? I1 is current flowing through this direction. That gives us v3 minus v1 over 6 plus 2 is 8. I2 is current flowing through this direction. v3 minus v2 over 4. Let me remove this. Yeah, let's not make it messy. And I3 is v3 minus again this ground node, because I3 is current flowing in this direction. So that gives us v3 minus vn over 8k equals 0. Let's erase this. Okay, so let's solve this one again. You can fast forward the video if you don't want to see the calculation. Vn is 0 was v3 over 2 minus v1 over 8, and finally minus v2 over 4 equals 0. So let's take 8 is common, and v3 4v3 minus v1 minus 2v2 equals 0. So our third equation is minus v1 minus 2v2 plus 4v3 equals 0. Now from all of these we have got our three equations, this one over here and this one. So let's put it all together as a matrix. That is 13 minus 4 minus 3 and minus 4, 13 minus 6, and here is minus 1, minus 2 and 4. And here is v1, v2 and v3. And on the other side we have 72, 0 and 0. So we have this matrix developed here. After solving all of this, we can get v1 is equal to 7.8, v2 equals 4.29, v3 equals 4.10. You can also solve this using your scientific calculator. I can upload a video later like how to solve three equations in your calculator. So I usually do that. And now we are not finished. Our main motive was to calculate V naught. From this circuit, you can see that V naught is always, let me erase this so that it will be easier for you to see. This was our V2 and this is our V3. So always check this positive and negative sign. Positive is at V2, so we write here positive V2, and negative is at V3, so minus V3. So our V naught is V2 minus V3. V naught equals V2 minus V3. That gives us V2 is 4.29 minus V3 is 4.10. So our final answer is 4.29 minus 4.10. That gives us 0.19 volt. This is our final answer. So, using nodal analysis, we can figure out V naught in any circuit. Thank you for watching this video. See you again in next video.